Today we're going to be testing the NV786630R1DAGEVB, which is a power LED, boost to buck 1.2 amp, 60 volt evaluation board from On Semiconductor. And we'll also be testing the NV786630R1DAGEVB, which is a power LED, boost to buck 1.6 amp, 60 volt evaluation board from On Semiconductor. The equipment we'll be using today include a DC power supply, set to an initial voltage of 13 volts with a current limit of 500 milliamps, an ammeter connected in series with the DC power supply at the input, and a voltmeter connected between the V-boost test pin and the ground bar. We'll also be using the NV786630R1DAGEVB, which is a power LED driver demonstration kit from On Semiconductor. Included are the motherboard, which the daughter board is connected into, ensuring that the white circles on the daughter board and motherboard are aligned. Next, we're going to connect the two LED modules to the motherboard. Next, using a phone cable connected into the motherboard's port, we're going to connect the motherboard to the SPI driver and connect the driver via USB into our PC. And notice that it powers up. Next, we're going to power on our 13 volt 500 milliamp power supply and check to see that the green power LED on the board powers on. To begin the test, we're going to launch our test software for the NV786630 kit, and we're going to click the SPI driver connect button and check to see that the program responds with an acknowledge message. Next, we're going to click the disable booster button to remove any default booster settings before continuing with the test, and check to see that our current consumption is between 2 milliamps and 20 milliamps on the input. Next, we're going to read our VBAT value via the ADC channel reading, and check to see that it's between 12.6 and 13.2 volts, which it is. Following that, we're going to read our V-boost value, also checking to see that it's between 12.6 and 13.2 volts. Following this, we're going to read our LED1 and LED2 values, ensuring that they are both at 0 volts. And lastly, we're going to read our VTemp1, ensuring that it is between 2.8 and 3 volts, as well as our VTemp2, which is also between 2.8 and 3 volts. Next, under the NV786630 application command window, we're going to update our range from range of 0 to a range of 2 to set our target voltage to around 29.5 volts. And we're going to click Update Booster. Next, we're going to apply a 3-pin jumper to our control pin between connectors 1 and connector 3. Next, to power on the LEDs, we're going to power on our duty cycle at 100%. After powering on both LEDs, we want to check to see that our output voltage on the board is between 29 and 31 volts, and our input current is around 250 milliamps. Next, we're going to change our current settings for channel 1 and channel 2 from 210 milliamps up to 960 milliamps for both channels. And then we want to click duty cycle at 100% once more. And once again, our LED should power on with a voltage of around 29 to 31 volts. This concludes the test of the NV786630 and the NV787630 evaluation boards. For more information, please visit www.onsemi.com or contact an authorized distributor.